Okay, many of you have seen this presentation before, so we'll concentrate on the new things. One of the bits of good news is the last time I presented this, I had a list about this long of I still have to, I still have to, I still have to. It's now much shorter, and we've included some of these new developments in the model. And of course, we'll keep doing it. Our latest one was how to use product line engineering in conjunction with mission engineering. So that's for a future presentation. Okay, for those of you who have not seen this before, the problem with presenting models to the DoD is you get everything is classified. And of course it is and should be. So how do you show examples? Well, this is why we came up with Star Wars. I would like to take complete credit for this, but my colleague John Holt in the UK actually had a Battle of Hoth model. It was completely different, concentrated on different things, but I like the idea, and this is why we did it. And my co-author, Matt Gagliardi, is having an absolute blast because it means he gets to model all sorts of stuff, and he was new to UAF, and now he's an expert. So the changes that we're showing you here are all in line with the changes that are going to be in UAF 2. And the purpose of developing the model was to try to say, okay, how do they work? What are the issues we run into? Are there different ways that we could do this? So this is like a proof of concept. Everybody knows what mission engineering is because we already had Hause explain that. So we'll keep going. We'll jump down to the last one. It's just systems and systems of systems in your operational context. And basically, I describe it as, can we do what we want with what we have? And that's a lot of the purpose of mission engineering. So the elements here, the mission thread, and the mission engineering thread, you've already seen this one, so we're skipping through. See how quickly we're getting through the slides? And this is the slide that Hause showed, and I would love to take credit for it, but it was James Martin. He always comes up with the most useful things, and he's just so annoyingly perceptive about what they are. So we absolutely love having him on the group. So basically, this is what he ended up with all the different areas here, personnel services. And as Jaime said, you don't need to do the whole thing. So you may say, actually, we need to look at the security aspects, or we need to look at some other aspect, or the system over time, or how different missions fit into one another, and so on. So what I did was create this set of elements, which is what is useful in terms of the standard UAF views out of the box for actually supporting mission engineering. The other thing I would mention is we've now authored 3 papers on mission engineering. One we gave at GV Sets. The next we'll be presenting at INCOSE yes, at the NDIA we presented it, also at INCOSE. That's going to be in Dublin, and we presented one at the last INCOSE as well. So if anyone wants those papers, do let me know. Send me an email, I'll pass them along. The model is also available, but we're currently updating it. So if you've got an older version, let me know. I'll send you an update. And when we've added 100% all the concepts, I'll send it out. So strategic capability, the why and the what before the how. What are our timescales? What are we trying to do? All the rest of these aspects. Operational, we have our logical architecture. Therefore, if we're defining the mission thread, what are we trying to accomplish? Again, you have this out of the box. Security, well, what are the risks I'm going to run into? How do I mitigate against these risks? How do I demonstrate that I've mitigated against these risks? Also, what are the security markings, security aspects, different security enclaves that you have as a part of your mission architecture, and defining those? One of the big ones is standards. And you think, well, standards, why? Well, if you've got comm systems and if you have other aspects, it's important. we did some mission engineering for the Army, and one of the most important things was at each step in the mission, how are you complying with doctrine? Because the doctrine aspect of it is extremely important because you have to demonstrate that I'm actually following the procedures. The other thing you get is, actually, if I follow the doctrine, I can't achieve the mission. So therefore, do we need to update doctrine? So it's, again, testing out all this stuff. The resources systems, well, this is obvious. How am I going to create it? What are my systems? What are their metrics, etc.? The human factors, because of course, how do people do these different things? Some of the things you could do, for instance, is apply tasks to personnel responsibilities. And then you can say, well, if I have an AI system that is performing this responsibility rather than the person do it, can I become more efficient? Can this soldier then perform more actions? So a lot of stuff in there. And also built-in traceability across all the different layers. I have a set of goals, capabilities, etc. Have I fulfilled all my goals? Okay. So let's keep going again. Jaime showed this one. He's stealing my thunder, but this is good because it just demonstrates how perceptive I am by using his slides and text and diagrams from the mission engineering guide. And we do love it. Again, this was something that James gave me, and this is actually looking at SR-71 mission profile diagram. So it's looking, as you see, at the different aspects, what you do and accomplish there. One of the things I'd like to do is actually model this at some point. All right, so to get to the brass tacks, these were the only changes that we actually had to make in terms of the profile to support mission engineering. And again, it goes to the point of why use UAF? Well, because you get all this out of the box. You don't have to take SysML, whack it with a hammer, and create your own personal domain-specific language. You can just use it as is for the most part. But of course, defining a first order element, which is a mission, that's a good idea. We probably ought to have one of those. Mission phases, mission threads, mission engineering threads. And then you have the missions are the mission definitions, and then the actual missions are the execution of those missions. So one of the things we originally had is we had a whole set of measurements dealing with, key performance parameters and other things. And we said, well, realistically, that's just simply a performance requirement. So get rid of it. So it was throwing stuff out that we looked at and said, we really don't need this. Now, for those of you who aren't quite geeky enough and haven't seen the Star Wars Battle of Hoth movie, I can't tell you how many times I've seen it. It was a battle that was fought in 3 ABY. If you go on this website here, they'll explain everything. It's just pages and pages of the Battle of Hoth. You can just have a great time. Anyways, Darth Vader came because he wanted to destroy the rebel base and he felt the force with him and said, okay, my son is there, so therefore we have to make sure he doesn't get hurt. So get Luke Skywalker was one of the main things. So anyways, they try to get out of there. So again, this is all the reasons why we're using it, and here's the basic elements. A mission. And we have two types of Empire mission phases, which is the execution phase and the planning phase. And invasion missions are made up of these two types of missions. And if you look at the invasion mission, types of invasion, as you can see, are scout landing and attack mission. And these are all part of the planetary invasion mission. So again, you can have missions within missions. Some of these can be the mission phases as you go along. And there's two attributes we defined from them, which was mission tempo and phase attributes, because of course, everybody's going to have their own names for phases. And in the Army, mission tempo is a very important aspect of this. So here is in fact an instantiation of the mission structure. And some of these things are what are called temporal systems, or temporal enterprise phases. And this is going to be renamed to be initiatives in the future. And what that means is that this mission happens before this other one. You can also have structural ones, which means both of these happen at the same time, but they're taking place in different physical locations. So you're able to mix and match and structure your missions in terms of time, location, phase, and so on and so forth. So it's rather powerful. And for each of the missions, as you can see, you look at the AMEP, which is which is the lowest one in the center there, Hoth AMEP. And this shows that you can specify what are the goals we're trying to accomplish, and more on those goals in a minute. In fact, right now, one of the things I looked at in looking at all these models, in fact, this is the text we have here, and we're supposed to destroy the defenses, prevent the rebel escape, and capture Luke Skywalker. Well, how does the evil empire actually attack planets? Well, they blow them up. As General MacArthur said, they execute their mission furiously. So we looked at this and he said, well, the problem is they can't do that because they need to keep Luke Skywalker alive. Therefore, I said, gee, it'd be nice if you had some means by which you can say, actually, this goal counteracts this goal. Or this one is in the same mission, but if you had this across multiple missions where you're saying, you're trying to do this, I'm trying to do the opposite thing, can we tie these together and say, do we need to fix this contradiction or was this intended? So it's similar to the problem statement, but it's calling it out and saying these two things oppose one another. And James Martin loved that relationship so much. He did a presentation yesterday. He had opposes on all his slides. I thought, okay, I have done my job. So this will be a new element. And as I said, we have learned so much for James, especially in the left side of the strategy side. And speaking of the strategy, StratML, I looked that up, and I think that's one of the things we're going to look into to see how much we can support these aspects. All right. You have your capabilities, so the planetary attack is made up of these different capabilities, and you're saying that this, the Hoth AMET, which is the attack, forgot what AMET stood for, but anyways, it's the execution phase, and it's the attack part of it. So we're just simply linking that to the highest level capability of planetary attack, as opposed to linking it to all the different elements. So it's an aggregation of these. And we're going to specify a set of metrics for this, and we'll see more on those in a minute. The UAF allows you to generate all sorts of different tables, and in fact, I have to admit it, MBAcq makes table generation incredibly simple, and you can make very complex ones with multiple links, etc. And so as a result, you can look at all your phases and say, have I identified all my goals? What is the operational definition? What is the resource definitions? What are the capabilities that I'm exhibiting on all of these? What are the different mission sub-elements? You can also do things like generate a model that shows you what does blaster fire look like as opposed to cannon fire, etc., where these are all energy, which is a natural resource. So you don't just specify information flows. I can actually show the flow of a battalion from this physical location to this other physical location. I think it's something that's not used as much as it possibly could be in UAF and DODAF architectures, showing the flow of a missile from here to that nasty Taliban base and ending up with a big hole in the ground. That's our intended result. Also, the data models. We kept it simple here, but you can define well thought out and well detailed data elements here. And one of the things that Mike Abramson's been looking at is, and I've finally, having taken all the security briefings, he was looking at what I call the problem of 2 + 2 = 6, i.e., I can know this and it's unclassified. I can know this, still unclassified. I know them both. Yeah, that's classified all of a sudden. So how do you actually model these relationships, and can we do it in these models? And it was originally called SOAPIes, and as I said, he's going to suggest this. So one of the things I want to do is write a presentation for NDIA and look at what would that look like inside of here. Would it be a separate thing or integrated? So you're able, as you see here, to break down your operational architecture here, i.e. here's the planetary invasion for the mission architecture. And I got the rebel forces at the top of the empire here. And by the way, if you haven't noticed it yet, we're the evil empire. We're modeling the evil empire's mission. It's kind of fun to be bad some days. It gets all your latent aggression out of you. So just pretend you're the evil empire for a day, you'll be fine. And one of the things we've done, I've got there the possible addition of friendly, enemy, and neutral, and that's in this model in just a second here. But being able to actually model all these. The other thing we looked at was, how do we know the value of those rebel forces? How do we know what their firepower is? How do we know how many forces they're actually going to be deployed? So one of the concepts we added, and this we didn't do a special stereotype, was a set of example provenance / where did this information come from? What is the source? What's our degree of confidence? And I'm sure as people use this, they're going to come up with additional attributes. And our intention is to build this up as part of the library. Again, why are we doing this? So that we can get this out in front of people and say, what did we do wrong? And what did we miss? How do we improve this? And how do we keep from overdoing this? And here's the example of the red versus blue. So as you can see, we kind of overdid it. All the stuff on the red has a big, on the left, sorry, has a big blue force stereotype, but you can also paint it blue as well. The stuff on the right is the red forces. So as a result, it's just simply shown as red there. And I can turn this on and off. I can look at the different types of flows that take place, turn those on and off. And that's what the legends get for you. I've really been having a blast with legends lately. Highly recommend you try them out. And then you can say, okay, what are the operational performers I have? And have I expressed all the different capabilities with these? Do I in fact have some performers here that have no capabilities that they're deploying here? And should I say, well, wait a minute, why is the Empire Scout Force a part of this attack plan? They should have been in the other one. I need to remove that from my architecture. So it's just all these built-in double checks, but you have to pay attention to them and realize what their purpose is. So that was the high-level structure, and then you have the lower-level set of these, where you have your mission thread at the very top, and then we have our sub-mission threads, as it were. Execute planetary invasion is the main thread. That's made up of scouting, weakening planetary offenses, attacking primary, and then we have mission tasks under those. Now, your mission tasks are the things that are specific to the mission. One of the things we assume is that you've already got an existing model of these different systems. You've got a list of the functions that they can perform, and that's what's going to be the next level down in this architecture. So you're building things up as you go. And it's one of the other reasons why on Tuesday we kicked off the reusable asset specification, so that way we can actually share and reuse models, model elements, and so on and so forth. So that's coming. We're hoping to have that 100% complete within a year. So you can see this here. I've got my performers, and these are all, as I said, something that already exists in my architecture. I know I have an air attack force, and these are the activities that it does. And so I build up a library of who are all the performers, what are the functions that they can perform, and these are modeled as operational activities. The other thing you can build into this are the UJITLs. And UAF has something that the British introduced that no one quite knew what to do with, which is called the standard operational activity. Those are your UJITLs. In other words, it's something which is specified and well documented. And again, you can show your traceability here. Across the top, we have our capabilities. And then going down here, we have the different missions showing what capabilities we have. And then making our way down for the different forces, i.e. my operational activity elements there, which capabilities am I expressing? And I can see I've got lots of capabilities supported by lots of these different activities. And again, if I have activities that don't link to a capability, I need to know why. Again, here's my rebel forces here. And I'm modeling what things we think that they can do. And we'll show you an example of the metrics in a minute. And then I model the different interactions here. Now, one of the things that we looked at is if you look, it says you fire on the enemy forces. Well, what do? They shoot back. What they also do is die and incur damage. And we've got emit visual signature, which is the information which is fed back so that you can do battle assessment. So in an activity diagram, it's action, reaction, action, reaction. And if you're going to surveil the enemy, well, they have to have something that they're passing on to you. And this was the emit visual signature. So it was working these out. Where do we come up with these? By doing missions for the Army and saying, wait a minute, how the heck do you do that? How do you do the back and forth when it's only one sentence? How do you show what both things take place? So we would also model, as you were pointing out, counterattacks as well, i.e. the fact that they're shooting back, modeling both sets of missions. But again, it's what we think their mission is going to be. And then here's the summary table, which is based around the information exchanges. And we're looking at it and saying, we never send a status message. How the heck can we not send a status message as part of a battle plan? So you can look at this and say, have I actually used up for this type of a mission all the different information elements that I have? And as you can see, I'm missing one. This one is tricky. You said, how do you model forces? If you model forces and you use the aggregation, that means those elements are permanently a part of there. And this is showing a legion, and it's made up of brigades and squadrons and all the rest of it. And what we did is we used the commands relationship. Now you're thinking, well, why would you do that? Well, this is the generic structure, and this is for the at. You see the little triangles? Those are the inheritance. So what it means is I can define what are the characteristics of a brigade, of a company, of a platoon. How many soldiers do they have? What type of equipment is common to all these different elements? And then as you see, if the far left there, I have a section leader, and the section at B leader and the at A leader both inherit from that. So it means that I can model their common characteristics, and I can say this is an at structure, and I can reuse it. I can also say, okay, here's a heavy mechanized platoon and organization. So these are the different systems along with the organization. So systems here, organizations here, sorry, systems here. And for this, I can put the specific element because I'm dealing with just those organizations and posts that are part of that. You can also do competency frameworks and the rest, but that's a whole nother story. And then I can show you, here's my mission engineering thread. And I can show the mapping of the mission engineering thread to my mission thread. And I can look at, say, weaken planetary defenses. Looks like we forgot to do that in the mission engineering thread. And on the left there, I've got maneuver to shield protect the Empire ground forces. Damn, we're not having a good day. And if you looked at the battle, this is exactly what happened. Remember, they shoot the Empire ship out of the sky and it crashes on the planet? Okay, you guys haven't seen it in a while. I can tell by the blank faces. It does. And why was that? Because they didn't weaken those defenses. So it's making sure that what you set out to do, you did. And again, here's where the tables help, because it says, this was my mission thread, here's my engineering thread, what did I miss? Here's the thing I was talking about with the intelligent info. So we created a generic thing called intelligence info. We've added provenance, confidence, and intel type. Under intel type, we kind of went nuts, and I looked on the internet. We got comment, elint, physint, humint, sigint, a bunch of ints, yeah? And what's your confidence, high, medium, or low? You might decide, actually, I want to put that as a percentage instead. And we've got here the Hoth Rebel Forces intelligence information, and I've got confidence intel type and exploratory probe data as the provenance. So, and then as up top there, I've got the fielded capability, and I've said this is a system that they actually deployed, and this is the information we have on it. The other thing we looked at, and this is one of the remaining to do, if I were to take that battle architecture, and this is just really the empire, and go down to the resources level, this is what the diagram looks like, which is slightly less than useful. So we're looking at what are some of the strategies for actually modeling these detailed battles. I mean, System Architect in the past was famous for having boxes so tiny you needed a microfiche viewer to read the diagrams. So we're trying to avoid that, and we're looking at, okay, on a common context, model the different parts of the mission and the different elements. You can also model the actual people who are in charge of the actual things and demonstrate that you've made all this up. Right, I am 18 seconds over my 25 minutes. So the model was built, as I said, proof of concept. So we're reducing learning curve, miscommunication, confusion, other things, other standardizations that were done were things like ROML, SysML, all the rest of it. This is why we're trying to standardize all these elements. I had a third slide that listed all the stuff I had left to do, but I'm only down to I need to have better models of the effects and outcomes, MOSs, MIPs, and we encourage any and all comments to make this a better model. Here are all my references and any questions, and may the force be with you.
I think we can take one question. Anyone? No questions?
Oh, why, thank you.
Some questions online?
I will take an accolade.
1 second, we may have some questions online.
I'll have a drink while I wait. It's just water, honest. So I say. Yeah, you're going to take my word for it, but don't come close and smell it. That's all I can say.
So here's one question online. Is the model available to download?
Yes, email me and I will send it to you. And our intention, email me and I'll send it to you. And our intention is to actually put it on the OMG website because we have different modeling communities. So we'll make it available, and certainly the profile. As I said, we did some more changes yesterday and I'm updating these now.
Perfect. Thank you.
Thank you.